Hello everyone, welcome to my channel, and it's a continuation of my lecture in geometry. Today I have a topic in geometry, especially on conic circles and straight lines in polar coordinates. Let me see what is the form of the conic circles, straight lines in polar coordinates. So before we start to the main topic, we have to look into the what is the definition of conic. So if a point moves in a plane, you know that in such a way that its distance from a fixed point always bears a constant ratio to its distance from a fixed straight line. Then the locus of the moving point is called a conic section or simply a conic. So if there is a fixed point, this fixed point is S, and there is a fixed straight line, L is the fixed straight line that is called the directrix, and there is a variable point P. You know that the distance from S, the point variable point, that is SP, and the perpendicular distance from P to the line, that is PN, is always bears a constant ratio, and that is equal to E. E is called the eccentricity. And you also know that if E equal to 1, it is a parabola. If E less than 1, it is an ellipse. If E get more than 1, it is an hyperbola. Okay. So this is the basic definition of the conic, and there are several criteria for that. And every conic, there is an important theorem also, every conic section is represented by means of a second degree equation. Now our focus is mainly on what is the equation of the conic in polar form. So let us have a choose a polar coordinate system. S is the pole and the polar axis is along the axis of C, directed from S away from the directrix G. So let's see, this is your polar axis is OX, and this is your conic. This curve, it looks like a parabola. This is your conic, and this is your fixed line G. G is the fixed point, okay, fixed straight line, and P is the any point on this coordinate on this conic r comma theta, and N is the foot of the perpendicular. So pole focus is S with respect to S as pole. The polar coordinates of P is r comma theta. So naturally this will be r, and this is your theta. And you have SP. SP is r, and so SP by PR equal to E, that is the eccentricity. PR is the length of the perpendicular from P to the fixed line. So you know from the definition of conic that SP by PR equal to eccentricity. Also, you can draw a perpendicular from P to the axis of the conic, so that foot of the perpendicular is N. Also, you can write PR equal to, this length is Mn, and this Mn equal to Ms plus Sn, right? And where Sn is r cos theta, you can write Sn as r cos theta. So you see, this is the calculation here, equation 3. This is given by equation 3. And let Q be another point on the conic that is perpendicular passing through the focus. So SQ is the semi-latus rectum. It is called semi-latus rectum. And this perpendicular is QT, the length of the perpendicular from Q to the line, fixed line. Again, you can apply the definition of the conic, that is SQ by QT equal to E. SQ by TQ equal to E. So from that, if SQ is the semi-latus rectum, that is denoted by L, then TQ is given by L by E. So again, you see your TQ equal to SM, right? You TQ equal to SM, and hence MS equal to L by E. Okay, MS equal to L by E from this equation. So from 3, your 3 is this, from PR equal to, you got MS equal to L by E. So it transforms to L by E plus r cos theta. So if you simplify, L by r equal to 1 minus E cos theta is the polar equation of the conic, that is equation 4. So what is the polar equation of a conic whose axis is away from the directrix? You look at the axis is away from the directrix. This is your directrix G, but its axis is away from the directrix, is directed towards away from the directrix. So its equation will be given by L by R equal to 1 minus E cos theta. So it's a simple proof using the definition of the conic. But if the polar axis is towards the directrix G, then its equation will be L by R equal to 1 plus E cos theta, okay, towards the directrix G. Also, if the polar axis is taken along a line inclined at an angle gamma to the axis of the conic, then the equation of the conic will be L by R equal to 1 minus E cos theta minus gamma, and L by R equal to 1 plus cos theta minus gamma. Accordingly, if the polar axis is away from the directrix, in this is the first case, and in the second case, if the polar axis is towards the directrix G. Okay, so these are the forms. Now, let us see what is the polar equation of the circle. What is the polar equation of the circle? Let us see what is the polar equation of a circle. Let C be the center and D be the radius of a circle. Take O as the pole and OX as the polar axis of a polar coordinate system. So let's see. Yeah, O is the pole and OX is the polar axis. C is the center of the circle and P is any point on the circumference of the circle, right? PR comma theta. So its coordinates is r comma theta. Theta is this angle, and suppose OC, that is the pole connecting the center, whose coordinate is rho comma alpha, right? Its coordinate is rho comma alpha. So this is the information given here. So these angles are XOP is theta, angle COX is alpha, and CP is D. The radius, this radius is D. Okay. Now you can apply your triangle law. You can apply your triangle law, that is properties of triangle, using cosine formula. So you can apply Cp square equal to Co square plus Op square minus 2AC dot OC dot OP cos COP. Actually, I'm applying this formula. I'm showing you the triangle also. This is your triangle ABC, right? And suppose this is the angle pi minus b, right? This is the angle pi minus b. So you can apply the vector method also, finding the cosines, right? Cos pi minus b. You can apply that cosine formula and it will give you this equation. So the equation of the circle will be very simple. You applying this formula, this is according to cosine rule, using the properties of triangle. D square equal to rho square plus r square minus 2r rho cos theta minus alpha. Thus the polar equation of a circle with D as its radius and rho alpha as the coordinate of its center is r square minus 2r rho cos theta minus alpha plus rho square minus d square equal to 0. So this is the polar equation of the circle, whose polar coordinate is r comma theta. Any point on the circumference is r comma theta, and pole is O and OX as the polar axis, right? So this is the diagram, and you are applying mainly properties of triangle, that is the cosine rule. Particular cases. Now there are some particular cases when the polar axis touches the circle. So if the polar axis touches the circle, then your diagram will be like this. Sorry. So this is the polar axis. If the polar axis touches the circle, so this is the center, right? Look at that, polar axis touches the circle. So this is your P is any point. So in this case, this is your R, this is your alpha. So in this case, your D is actually rho sine alpha, right? This is your rho. So in this case, you can see from the diagram, D is actually rho sine alpha in this case. If the polar axis touches the circle, you can get this from the diagram only. Hence, you can substitute in the equation of the circle. D square is equal to rho square cos square alpha. So rho square you can take, and 1 minus cos square is sine square. So you will get this equation. Yeah, this is the equation. So this is the case 1 when the polar axis touches the circle. Now, when the pole is on the circle, so when the pole is on the circle, let's draw a circle now. 1 second. So this is a circle. If the pole is on the circle, then this is the thing, this is your polar axis and this is your pole, right? This is your center C and this is your P. This is your P r comma theta, right? This is your P r comma theta. So this is the thing. So this is your alpha, this is your theta, right? So in this case you have rho equal to D actually. Rho equal to D, you see from the diagram, OC equal to actually the radius, so that is equal to D. So rho equal to D, hence the equation will be in this form, r square equal to r equal to, sorry, it would be r equal to, because r square get cancelled, so it is r equal to 2d cos theta minus alpha. So this is the second case when the pole is on the circle. So this square should not be there, it is only r equal to 2d cos theta minus alpha. And in the third case, when the pole is on the circle and its center is on the polar axis, then you have center is on the polar axis. So you see this is the diagram and this is the polar axis and your center is on the polar axis. This is your pole, this is your polar axis. In this case you have alpha equal to rho equal to D. Your in this case you have rho equal to D and alpha equal to 0 actually. Alpha equal to 0, sorry, you have a, okay, so you have alpha equal to 0, there is no angle, so alpha equal to 0, hence the equation will be in the form of r equal to 2d cos theta. This is the case 3. And case 4, sorry, in this case also alpha equal to 0, when the pole is at the center of the circle, when the pole is at the center of the circle, in this case you have, this is the case, this is misprinted here. In this case you have rho equal to 0, this is case 4, because when the pole is at the center, okay, so rho equal to 0 and r equal to D, okay, r equal to D. So this is the equation, this is the form actually. And case 5, oh, there is only 4 cases when the pole is at the center of the circle. Okay, everybody. So rho equal to 0 in this case. If you draw the diagram, you can get everything. So this is the equation of the polar form of the circle and its different cases. Now, what is the polar equation of a straight line? Very simple. Your Cartesian form of the straight line is ax plus by plus c equal to 0. And if you replace your xy by r cos theta, r sin theta, your polar equation of a straight line is given by a by r equal to a cos theta plus b sin theta, a equal to minus c. So you can just, a is a constant, a is minus c, which is the polar equation of the straight line. So this is the polar equation of the straight line. Sometimes the polar equation of the straight line can be written as L by r equal to a cos theta plus b sin theta, right? This is the form also L, because L is the usual notation in polar form of the conic also. Now we have a very important question. What is the polar equation of the chord of a conic? So this is very important question for all the students. Polar equation of a chord of the conic, if you take the conic in the form L by r equal to 1 minus e cos theta with alpha minus beta and alpha plus beta as the vectorial angles of its extremities. So you have two chords. This is the conic. So this is P and this is Q, suppose. So this is the chord of the conic. So P has alpha minus beta as the vectorial angle and Q has alpha plus beta as the vectorial angle and R1, R2 as the respective radius vectors, right? So P's coordinates is R1 alpha minus beta and Q's coordinate is R2 alpha plus beta, right? So the equation of the line PQ can be written as L by R equal to a cos theta plus b sin theta. Since R1 alpha minus beta and R2 alpha plus beta are the points on the conic, then from 1 we have, it will satisfy the equation of the conic and also the equation of the line PQ, right? So if you replace, this is the equation, if you replace, this is R1 alpha minus beta, R2 alpha plus beta, right? And if you take this in this form, this is a simplified form, that is equation 2 and equation 3. You see there are two unknowns a and b, and you can solve for a and b by cross multiplication method, by any other method. That choice is yours. You can solve that. And after solving 2 and 3, you will get the values of A and B. So these are the values of A and B. A and B are given by this. So hence one takes the form L by R is equal to sec beta cos theta minus alpha minus E cos theta, right? Thus the equation of the chord joining the points theta equal to alpha minus beta and theta equal to alpha plus beta on the conic L by R equal to 1 minus E cos theta is L by R equal to sec beta cos theta minus alpha minus E cos theta. So this is the answer. This is you have to evaluate. This you have to prove. So this is the equation of the chord joining the points alpha minus beta and alpha plus beta. Okay. Next, if the equation of the conic be L by R equal to 1 plus E cos theta, what will happen? You will go to the same process. Your answer will be, instead of minus, there will be plus. So I will discuss that also. Yeah, this is the form. You look at that, there is a plus sign. Same thing, same calculation, same process, same technique you have to apply. Now next question is, if the what is the polar equation of the chord of the conic L by R equal to 1 minus E cos theta with theta 1 and theta 2 as the vectorial angles of its extremities? In that case, your theta 1 is equal to alpha plus beta and theta 2 equal to alpha minus beta. So if you replace, then you can easily solve beta equal to theta 1 minus theta 2 by 2 and alpha equal to theta 1 plus theta 2 by 2. So if you substitute in 4, you will get L by R equal to sec theta 1 minus theta 2 by 2 cos theta minus. Just you are replacing in the same equation. In the previous equation, look at that, your alpha and beta. You are just replacing your alpha and beta by these values, theta 1 plus theta 2 by 2 and theta 1 minus theta 2 by 2. So you will get equation 5. Right? This is your equation 5. Okay? Okay, everybody? This is your equation 5. So this is another question, but you have the first, you have to do that process. So this is your plus, already talked about this. And if it is tangent, now the question is what is the equation? Okay, in this case also, if your polar equation is L by R equal to 1 plus E cos theta, then this will be plus here. Okay, so you have the same proof, same technique, just you need to change the sign. Now the polar equation of the tangent to the conic. What is the polar equation of the tangent to the conic at the point whose vectorial angle is alpha? Now you have to prove, first, before you going to the tangent, you have to prove the polar equation of the chord of the conic with alpha minus beta and alpha plus beta as the vectorial angles is given by this equation. This is the chord of the conic. Just already we proved that. If beta equal to 0, then the line corresponding to the chord becomes the tangent to the conic, because you know, limiting case, tangent will be the chord will be the tangent actually, whose vectorial angle is alpha. So if beta equal to, so you have to write this. Thus the equation of the tangent at theta equal to alpha is given by this. If sec beta is 0, sec 0 is 1. So this is the equation of the tangent. And if you consider L by R equal to 1 plus E cos theta, so here you will have a plus sign. So what is the difference between the chord and tangent? You have to go through the same process as you have gone through by proving the chord. Now in the tangent, you have to substitute beta equal to 0. Then the equation of the chord becomes the tangent to the conic. So at theta equal to alpha, it is given by L by R equal to cos theta minus alpha minus E cos theta, right? And if you consider the plus sign, it will be L by R equal to cos theta minus alpha plus E cos theta. Okay. So you have 5 or 6 proofs, all are similar. The main important proof is proving the equation of the chord, and all other proofs are auxiliary proof with the help of that proof. Lastly, there is an assignment for all my dear students. What is the polar equation of the normal to the conic? You know that normal is perpendicular to the tangent. So this will be the result. Okay. And you have to prove this. This is your assignment at the last of my lecture today. Okay, everyone. So this is a very important lecture in polar form of a conic, circle, different forms of circle, and also the equation of a straight line, equation of the chord of the conic, equation of the tangent to the conic, and equation of the normal to the conic. And with the help of this theoretical knowledge, you can solve so many problems in your book. Okay, all of you. Thank you all of you for watching my videos, my lectures, and I will post my next video in geometry very soon. Thank you, all of you.